Welcome to this explainer. Today, we're going to fundamentally transform how you write C++. We're talking about making your custom objects behave exactly like those standard built-in data types you use every single day. It's all about taking your code from feeling clunky to being completely seamless.
So think about this for a second. Imagine you've just spent hours crafting this beautifully complex custom clock class to track time perfectly down to the second. But when you actually go to use it in your main program, why does interacting with it feel so much clunkier than just, say, adding two standard integers together? Why do our custom objects always seem to feel like second-class citizens in our own code?
Well, this comparison brilliantly illustrates our core problem. On one hand, you have the clunky way. Calling traditional function names like equal time just to do basic math or comparisons, it's tedious and honestly, it totally breaks your flow. But then you have the elegant way, simply typing my clock equals your clock. That right there is exactly where operator overloading comes in to save the day.
Here's our roadmap for today. 1. The magic of overloading. 2. Syntax and hard restrictions. 3. Understanding the this pointer. 4. Meeting your friend functions. And 5. Mastering stream operators.
All right, jumping right into section 1, the magic of overloading.
Notice how we declare a function here named operator equals equals. What we're doing is literally teaching the C++ compiler exactly what to do when it sees a double equal sign sitting between two clock objects. Instead of the compiler throwing a fit and giving you an error because it doesn't know how to compare custom clocks, it looks at this specific function, checks the hours, minutes, and seconds, and just returns a Boolean. It feels a bit like magic, but you're entirely in control.
Moving on to section 2, syntax and hard restrictions.
Now, before we go wild and rename every single function to a math operator, we do need to know the rules. The syntax itself is pretty straightforward. You just need a return type, the keyword operator, the actual symbol you want to overload, like a plus or an equal sign, and then your parameter list. But while writing it is easy, C++ does enforce some strict boundaries.
The crucial thing to remember is that you're enhancing existing operators, right? You aren't changing the fundamental laws of C++ math or inventing totally new symbols. So no, you can't invent an @ operator out of thin air. You definitely can't change precedence to make addition happen before multiplication. Default parameters are totally forbidden here, and specific structural operators, like the dot operator or size of, are strictly off limits. We absolutely have to play by the language's core rules.
Next up, section 3, understanding the this pointer. To really make these operators hum, especially when we're stringing multiple operations together, we have to introduce a hidden identity tag that lives inside every single object you create. Think of the this pointer as a built-in GPS for your object. When a member function is running, it sometimes needs a way to refer to the exact object that called it. The this pointer lets that function say, hey, return times me, the entire object, as one whole unit. And here is the exact payoff of doing that. By having our functions return the dereferenced this pointer, which is just an asterisk right in front of the word this, you can actually chain commands together. You can set the length and then immediately set the width of a rectangle, all in one single fluid line of code reading from left to right. The first function finishes, returns the object itself, and just passes it right along to the next function.
Let's hit section 4, meet your friend functions.
So, what happens when an operator needs deep access to your class's private data, but technically shouldn't belong to your class as a member? Enter the friend function. I like to think of these as VIP backstage guests at a concert. They aren't actually in the band, they aren't member functions, but because their name is on the VIP list, they have unrestricted clearance to see and modify all the private data.
Let's compare how this actually builds out. On the left, we've got a binary operator overloaded as a member function. Since the object on the left of the symbol is the one invoking the function, we only have to pass the right-hand object as a parameter. But check out the non-member friend function on the right. Because neither object actually owns the function, both the left and right operands have to be explicitly passed in as parameters. Keep this distinction in mind because it's absolutely crucial for our next topic. Which brings us to section 5, mastering stream operators.
This is where everything we just talked about comes together perfectly, standard input and output streams. Think about how you print in C++. You type cout, followed by the insertion operator, those two less than signs, and then your variable. Now, because the left side of that statement is cout, which is an OStream object and not your custom class, that insertion operator cannot possibly be a member of your class. The left operand dictates the calling object. So to print custom objects, that insertion operator literally has to be implemented as a non-member friend function.
Let's break down how chaining those outputs works step by step. When you write cout insertion operator myrect insertion operator yourrect, the compiler reads that from left to right. It takes cout and myrect and throws them into our friend function first. But here's the trick. To keep the chain alive for yourrect, our function has to return that stream object back out. It catches the stream, prints the first rectangle, and then tosses the stream right to the next operator in line.
And here's your master blueprint for making it happen. If you followed this specific syntax pattern, passing both the OStream and your custom object as reference parameters and making sure the function returns an OStream reference, you will seamlessly integrate your custom object right into the standard C++ ecosystem. You can finally use cout on your custom rectangles or clocks exactly like you would on a standard integer or string.
At the end of the day, this is why this technique is such a game changer. As our source material perfectly puts it, operator overloading provides the same concise expressions for user-defined data types as it does for built-in data types. It's the ultimate tool to elevate your custom classes from feeling like awkward bolted-on add-ons to native first-class citizens of the C++ language.
So, as you head back to your code and start designing your next custom class, I want to leave you with this thought. Which standard operators will you overload to make your code practically write itself? The power is totally in your hands to make your custom types brilliantly elegant. Thanks for joining me on this explainer, and happy coding!